This is Josh White with JW Math Tutoring. In this video, I'm going to cover Bluebook PSAT 10 Practice Test Number 2, Module 2A, the easier of the two second modules. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Before I start going through the solutions to this Bluebook PSAT 10 Practice Test Number 2, Module 2A, just want to mention a couple things. First, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And second, please check out the solutions in the other videos for Module 1 of the same test, and also Module 2B, the harder of the two second modules. All right, so with all that being said, let's go ahead and get started here. Question number 1, you are given a bar graph. How many containers contain exactly 78 walnuts? So we see the line here for 78, and it goes up to 7 on the y-axis. Therefore, the correct answer is letter B. Next up, question number 2. This is just a basic percentage problem. We are finding 10% of 320. So that's just 0.10 times 320, which gives us 32. Now, just to show you real quick, you could also just go to Desmos and you can literally just type it in using the percentage sign, 10% of 320, and right there it's 32. So just something else to make sure that you're aware of. Next up, question number 3. It's just basically a rate problem. This device produces 60 items per hour. How many will it produce in 3 hours? Well, it's just 60, think about it, unit conversion, 60 items per hour times 3 hours. The hours cancel out, 60 times 3, and you get 180. So, or 180 items, and that's the answer to this problem. Next up, question number 4. Here you have the graph of a line. What is the y-intercept as a coordinate point? It is right here, 0, 2. So the correct answer for this one is just letter C. Next up, question number 5. What's the positive solution to this absolute value equation? So technically, when you have an absolute value equation, you set up two different equations. One equal to the number you see on the right, the other equal to the opposite of that. The positive one is going to be found by solving this first equation, which is x equals 3. Negative 1 you would get by solving the second equation, but we don't have to do that for this problem. So the correct answer is going to be 3. Two things. You could also solve this by back solving. And if you're going to do that, I would just go to Desmos. And, I would just type in here basically, start with the first answer choice, 3 plus 45 in absolute value signs. Does it equal 48? Yes. If you check all the other answers, no, not equal to 48, no, not equal to 48, no, not equal to 48. So you could back solve this and do it that way. Or you could just solve this by typing out the full equation like this and then looking for the vertical lines. Notice the negative solution is way over here at negative 93. Now you can't click on it. That's the only thing with an absolute value equation. You can't click on it, but you can clearly see here when you zoom in, it's directly on 3, and that's the only answer, choice that's anywhere near that value. So that's just an alternate way you could use Desmos to solve this. All right, next up, we have another graph here, specifically a line graph. Which day had a 30% probability? Okay, well, it's obviously going to be the one which has this point right here. So the correct answer is just letter C. It is Thursday. Next up, we have a graph of a system of equations that are intersecting at one point. What's the solution? Well, it's just this point right here, which looks like it is negative 2, 6. Therefore, the correct answer to this problem is letter B. Next up, question 8, you have a system of equations. But here they give the equations, not the graph. You want to know what is the y-coordinate of the solution. So since x is already solved for a number, all you really have to do here is just plug in the x value, and then when you do that, you get 5 minus 4, which is just 1. So the correct answer to this is going to be letter A. Of course, solving systems of equations, we could just go to Desmos, and we can graph both lines, and we can see where do they intersect. Right here, 4 comma 1, they want the y value, the answer is 1, same answer I got originally. All right, next. Here you have a problem where it's basically saying this geologist has collected 63 samples already, needs to collect some number more so that you have at least, i.e. greater than or equal to 67 samples. So what's the minimum number? Well, notice it's just the value you get by subtracting 67, the number you need, minus 63, the number you have, so it's 4. Needs at least 4 more samples to add to a 63 to reach 67. All right, number 10 here, we have a graph, looks like some type of polynomial. What's the y-intercept value, specifically the y-coordinate only? Well, we can clearly see here it is going to be 40. And we just type in the value. We don't type it as a coordinate point, with parentheses or with the x-coordinate. All right, next, what is the value of x for this given equation? So here, if you notice, 8x minus 7x, that's just 1x plus 130 equals 260. Subtract 130 on both sides, x equals 130. So that's our answer. That's what we would type in. But, of course, if you wanted to, you could solve this in Desmos. You can just type the whole thing. Then you have to look for the vertical line. Now here I'm going to have to zoom out a bunch of times, and then you can see it's right here. It's at 130. So that's our answer. It's an alternate approach you could take to solve it. Next up, what is the x-coordinate of this graph of this curve? It looks like an exponential function. So right here is the x-coordinate. Appears to be at the point 6 comma 0. So again, here we're only entering in the 6. We are not entering it as a point. We are just entering the x-coordinate value from the x-intercept. Next up, you have basically a word problem where they want you to come up with the equation that represents this situation. And this is basically going to be a linear function. And specifically, you have the $35 kind of like as your b value or as your y-intercept value. Essentially, your starting amount that you owe even before any months of the service have been used. At 0 months, you pay $35. And then the monthly cost, that's your slope. That's how much the cost changes per 1 month of service. That's the $23. So this is just going to be y equals 23t plus 35. Correct answer is going to be letter C. Next, you're just evaluating a function here, technically a linear function. So we're just taking x, we're plugging in 7 for it. 3 times 7 is 21. 21 minus 8 is 13. So the correct answer here is going to be letter B. But I will show you could also have just gone straight to Desmos for this. Typed in the function. And then just do f of 7. Just type that in, gives you the correct answer of 13. Next up, you have 2 lines that are intersecting here. They tell you W is 136, so what does Z equal? Well, the correct answer is D. It's the exact same value. It is also 136 because these are vertical angles. These are angles that are across from each other when you have 2 lines that intersect. Therefore, they are congruent. They have the same measure, so Z is 136 also. Next up, question number 16. So, you're told the area of a rectangle is 57 square inches. The length of the longest side is 19. What's the length of the other side? So we know that the area is just equal to length times width. So it doesn't matter which of these you technically designate as the length or the width. The point is, one of them is 19. The other one is some other number. Therefore, divide by 19 here, let's just say it's the width, is going to be 3. So the shorter side of this rectangle has a length of 3 inches, and that's it. That's what we would type in. Next up, we have an equivalent expressions problem. So initial way to do this by hand would just be to distribute the 19 here, and you get 19x squared, and then minus 19 times 7, which is 133. So the correct answer for this one is A. However, this is one that can also be solved in Desmos. So what you would do is you would type the original expression. This is basically matching expressions, this technique. And then you go through and you type the answer choices, and you see which one overlaps the original expression completely. Notice for text way down here, negative 133. Okay, so notice this one overlaps it completely, so that just basically confirms it's the correct answer. And if you look at all the others, you will see they do not overlap the original completely. And we can do the last one there. See, it's even way up here. So this just confirms the correct answer is going to be letter A. All right, here you are just evaluating another expression. However, this one, when you go to find f of 0, it's actually going to be done fairly quickly because the 0 squared here is just 0, and 0 times anything is 0. So this whole term just becomes 0 and drops out. And then same thing here, negative 32 times 0 is just 0. So it's like 0, 0, those don't matter. The answer is just negative 152. Really, it's asking for the y-intercept value of this function. Now, of course, we could do this entirely in Desmos. And then you just do f of 0, and it's negative 152, and then we have our correct answer. It is letter A. All right, next we have another system of equations here, but again, it is already, one of them is already solved for x, so we can just take that and plug it in here, and then 15 minus 3 is 12. 12 squared is 140. Wait, what am I looking at here? 15 minus 3 is 12. Oh, 12 squared is 144. Yes. However, notice here we want xy. Not x, not y, but the product of them together. So you have to take 3 and multiply it by 144. And when you do that, you're going to get 432. Correct answer for this one is letter A. Now, as I mentioned with all the other system of equations problems, you could do this one in Desmos. And what I would do is, after graphing both of them out, find the intersection point right there. Then I would export it. And then I would get rid of this, and replace this with a multiplication sign. Oh, delete the comma. There we go. 432x times y. And we have our correct answer. So this is just an alternate way that you could do that problem. All right, next up we have a word problem. So essentially what's going on here is you have two things being multiplied, product of two positive integers. Okay, x times y equals 462. If the first integer, we'll call it x, is 5 greater than, so it's 5 more than something, twice the second integer, what is the smaller of the two integers? Okay, so now what you can do is basically take this and plug it into here and solve it all out. However, actually, yes, let's do that method. I'll come back and talk about another way you could do this problem entirely in Desmos in a little bit. Okay, so if we do that, notice really you get 5 plus 2y times y equals 462. So now let's go to Desmos. I'm just going to solve this in Desmos. There's no reason to bother solving this by hand because I can just graph this. It's a quadratic, and I can just look for the x-intercepts. Or actually, no, sorry, it's not going to be x-intercepts. It's going to be It's going to be y-intercepts because it has only y's in it. So we get 14 or negative 16.5, which those are the two values you get if you actually solve it out by factoring. Okay, this is not a positive integer, ignore it. All right, so one of the answers is 14. The other answer is presumably going to be something larger than that. Because notice here, x is equal to 5 plus 2 times 14. Okay, 5 plus 28. So the two numbers are basically 14 and 33, meaning these are the two numbers that you multiply to make 462, and one is 5 greater than twice the other. Okay, 14 is obviously the smaller of the two, so that's your correct answer. So that's what you would type in. Now, what I wanted to show originally was if you set up the initial system of equations, i.e. the product of two integers is 462, and you know that one is 5 more than 2 times the other, you don't actually have to substitute this in. You could just, once you get the two equations, you can just graph them and look at the solution points. Okay, notice these values are not positive. We ignore them. They don't apply. They're not, a solution to this specific problem. Right here is the solution to this specific problem, and it's the 33 and 14 that I just got. So now when you look at these, you would say, okay, what is the smaller of the two integers? Well, it's 14. So that's your correct answer. And that's how you, once you set up the system of equations, that's how you could do the entire thing in Desmos. Okay, next up, we have another equivalent expression problem. So this one, you're not distributing it out like the one a couple questions ago. Instead, you are factoring, this as a difference of squares. So this is going to be x plus 10y, x minus 10y, and then you also have the 17 that's out front. So now when we look at the answer choices, it's going to be D. I mean, they have the parentheses in a different order. They have the minus 1 first and the plus 1 second, but that doesn't matter. They're equivalent. Multiplication is commutative. You can switch the order of the entire parentheses for this problem. Now, let's look at Desmos and see how you could do this problem entirely in here. All right, so here's the original expression. Now the problem is, notice, it's not graphing it as it's given. It's giving you an error that you need to turn this into an equation. So sometimes what you need to do is just add an equal 0 here, just to give it whatever random graph it happens to turn out to be. It doesn't matter. We're just basically looking for the same graph as the original. Okay, so notice answer choice A, not the same as the original. Doesn't overlap it completely. Answer choice B, not the same as the original. Now, answer choice C, not the same as the original. Part of it's the same, but the full thing is not the same. However, notice when I do this, okay, it has a bunch of this bouncing back and forth here, but technically you can see that it does overlap it entirely. So this is just the correct answer. Now, a little shortcut you could use to get around this, back with the y here, is if you want to use this approach in Desmos, change this to an a, okay, and then just set a equal to whatever number, whatever, 1.2 via a slider, and then do all your answer choices with a. And now it's a lot easier and cleaner to see that, yes, this one overlaps it entirely. But if you did, for example, this one here, notice it doesn't overlap it entirely. The vertical lines are not shared. And you see the same thing for A and B. So this is just a little tip or trick where if you're having problems getting the graph because it's got like an X, X's and Y's in it, just change the Y to some other letter, define that letter using a slider, and then look for the overlap. All right, last question here. How many solutions does this system of equations have? So if you want to, if you were going to solve this one by hand or kind of look at the theoretical approach, basically what you would be looking at is what's the multiplier between each of the two terms. each sets of terms, meaning x's and y's and numbers. So for example, here, -6 times 2 equals -12. That's the x multiplier, is basically +2. And here, 7 times 2 equals 14. However, here, notice it is different. It is not the same. It is -2. So in other words, x and y have the same, what I call multiplier, or you could also call it a scale factor, but the number terms are different. They have a different multiplier, different scale factor. That means this is going to be no solution. In other words, it's letter D, there are 0 solutions. If all three are the same, then it is infinite solutions. Because that means that one of the equations is just a multiple of another equation. It's really the same equation twice, just one of them is multiplied by some value for all the terms. For it to be one solution in an example like this, where there's two linear equations, the x's and y's would have to have different multipliers. Okay, so the x and y would have to basically be different, because that would make their slopes different, essentially, is what's going on here. All right, so that being said, the quicker, fastest way to do this one is to actually just go straight to Desmos and just graph both the lines out and just see visually what happens. So there's the first line. Here is the second line. Okay, how many solutions are there? Well, there's clearly not one. It doesn't look like they intersect. There's not two. Two lines, linear equations are never going to intersect twice. It's either 0, 1, or infinite. So that's out. It's clearly not infinite. For it to be infinite, it'd have to be the same line like over top of itself, and that's not what's happening here. And it's D. It's 0. Notice there's no solution. They are two parallel lines, so this is something that you could honestly do much quicker and much faster just in Desmos. All right, so I hope you enjoyed the solutions and explanations to this Bluebook PSAT Grade 10 practice test number 2, module 2A, the easier of the 2 second modules. If you did, please give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods, please feel free to leave them down below in the comment section. Also, if you haven't done so already, check out the videos to Module 1 from the same test, and also Module 2B, the harder of the 2 second modules for the same test. And lastly, if you're looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It is over 6 hours of tips and tricks and instruction and 65 practice problems to help you ace the digital PSAT and SAT math sections.